Right, now we're looking at lesson 2.3, which is all about slope. We've looked at slope and how it relates to linear equations before in previous classes, different topics from algebra before. So this should be basically a review. We will also review a little bit in this lesson the form y equals mx plus b. So try to remember y equals mx plus b, and as well remember specifically what that m stands for. That's our slope. Okay, so looking over just specifically finding a slope, finding our m value, here is our formula. Anytime you're given 2 points, like in this first example here, we have 2 points, your second y value minus your first y value goes on top. Then on bottom, it's your second x value minus your first x value. Okay, in a way you can think of that as rise over run, or it's your change in y value over your change in x value. How far up or down you're going versus how far left or right you're going. Okay, now as long as we read, which we normally do, from left to right, this x value should be getting positive. Your run should always be positive going from left to right. Sometimes though, when we're looking at these points with these numbers, we might not know which one is left and which one is right. So this might become negative. That just means we're reading from right to left, and our slope in the end should equal itself out. And I'll show you what I mean by that as we work through our example. So for the example, finding the slope of the line that passes through 1, 3 and -2, -3. Let's first plot those points. So 1, 3 be 1 over 3 up. That would be this point. -2, -3 would be -2 over, and then -3 down right there. So those are our 2 points. We're trying to find the slope of the line that goes in between these. So again, that's like how far up or down you're going and how far left or right you're going to go from one point to the next. How we can figure that out? Just plug it into this formula. Notice here was our second point, here was our first. So when we're plugging these in, -3 and -2 are our y2 and our x2. -3, -2. They always go first. Okay, then we're subtracting y1 and x1. Okay, so we're subtracting this 3 and this 1. Subtract 3, subtract 1. Okay, so this is how it would first look just by plugging it into the formula. Then we solve it out. -3 minus 3 is -6. -2 minus 1 is -3. Negative over negative is a positive, and 6 over 3 makes 2. So if it helps, remember you can write in that it's a positive 2. You can also think of this as 2 over 1. -6 over -3 simplifies to 2 over 1. What that's saying is, as we're going from one point to the next, because these are both positive, this being positive means up to, this being positive means we're going in the positive x direction, so right 1. Up to, right 1. Up to, right 1. Up to, right 1. And it lands right where we wanted it to. And it would continue to go up to, right 1. Similarly, with it being negative, -6 and -3, think about going from this spot, going down 6, and then in the negative x direction, 1, 2, 3. That's how we go from this point all the way down to this point. So if we went another -6, -3, so we go -1, 2, 3, 4, 5, 6, -1, 2, 3, we could get right here. So this point to this point, doing both as negatives. But let's double check again using as the positive. -6 over -3, remember, should be the same as positive 2 over 1. So going from here, up 2 over 1, up 2 over 1, up 2 over 1. It still fits directly in line. So this slope between the 2 points, we could just call it the positive 2. If you like writing it as the fractions, because it helps you remember the rise and run, it'd be 2 over 1, both of them being positive. Okay, now when we need to graph the line, we just plot these 2 points like we did, and just draw a straight line between them. Okay, so anytime that you need to graph, just plot the points and connect them. That is how you draw your straight line. So let's do that again for our next example. Find the slope of the line that passes through -1, 4, and +1, -2, then graph the line. Well, like before, let's plot those points. -1, 4 is right here. +1, -2, that would be this point right here. So we use our formula, y2 minus y1 over x2 minus x1. In this case, y2 is -2, so that goes right here. y1 is 4, so that goes right here. x2 is 1, so that goes right here. And x1 is this -1, so that's going to go right here. So this is our slope formula kind of spelt out. -2 minus 4 and 1 minus -1. So we spell that out. -2 minus 4 is -6. 1 minus a -1. Remember, if you minus a negative, that's like just calling this plus. Minus a negative is the same as just adding, so 1 plus 1 is 2. We have -6, 2. Now what this tells us is down 6, because this is positive, we're going right 2. Down 6 and right 2. We can, however, reduce that or simplify it even further to just being -3. And again, if that helps, think of it this way, think -3 over 1. Down 3 over 1. Same as going down 6 over 2. So let's just double check that. From this point, if we go down 1, 2, 3 over 1, we'd hit right here. Down 1, 2, 3 over 1, we'd hit here. Right on the point we're supposed to. A couple more points if we want. 1, 2, 3 over 1. 1, 2, 3 over 1. And again, you can kind of double check. Do these all fit this down 6 over 2? Does down 3 over 1 mean the same as down 6 over 2? Coming from this point, down 6 over 2 gets us here. Down 6 over 2 would get us here. So they would still fit in that down 6 over 2 is the same as down 3 over 1. Okay, they mean the same, but this would just be the most simplified way to say it. The slope would be -3. Now, same thing, if we need to graph this, we just take these points and connect our line. That would be the graph of the line that goes through those 2 points. If we need to use our slope to graph a line, that'll change things up just a little bit. If we need to graph the line that passes through 1, -3 and has a slope of -3/4, well, to graph this, first plot your point. Then plot a second point using that slope. So we don't know what that second point is until we actually use the slope to find it. So you're going up or down the rise amount, and you're going right that run amount. Then connect those 2 dots in a straight line. So our point was 1, -3. That's right here at 1 over, -3 down. We're going to use the slope of -3/4, which means from here go down 1, 2, 3, and over 1, 2, 3, 4. This is going to be our spot, down 3 over 4. And now we're just going to connect those 2 with a straight line. It'll look like that. And I guess I can use my technology here to straighten out that line, go all the way. With you, on your sheet, you can just put a ruler down on those 2 points and just draw a line between those. That would be how to graph using this 1 point, this 1, -3, and the slope of -3/4. Down 3 over 4, you found your new spot, connect them with a straight line. And that's how you graph using just 1 point and the slope. Let's do that again then. Graph the line passing through -4, -3, and has a slope of 2/3. Well, we're going to plot the point, -4, -3. It's right here. Slope of 2/3 means go up 2 and over 3. That would get you right here. Now all we got to do is connect that line. It's going to go right there. And if we extend it, it's going to go right there. So that would be our line that goes through -4, -3. This green spot right here has a slope of 2/3. So remember, up 2 over 3. And if you want to double check, you can hit all those points then. Up 2 over 3 right there. Up 2 over 3 right there. Up 2 over 3 right there. We hit all of those points that we were looking at going up 2 over 3 from our dots there. We're going to look at parallel and perpendicular lines in our next video.